Hi, welcome to this lesson on Euclidean geometry, circle theorems, the center to chord and converse theorems. Let's have a look at question 3. We have given a circle with center O that has OT perpendicular to SQ and OT perpendicular to PR. We have that OP is 10 units, SQ is 10 units, and PR is 16 units. We want to determine the value of TU. So in the diagram, let's list all the information we've been given. We have a circle with center O, so that's important. We know what the center point is. We have that OT is perpendicular to SQ, and we have that OT is perpendicular to PR. So these are the chords in the circle. Okay. We also have that OP is 10 units long, SQ is 10 units, and PR is 16 units. The goal here is to find the length of TU, which is the short distance here. So if we look at this diagram, I can see two right angle triangles. Okay, so the first one I see is this triangle here, PUO, where OP was given as 10 units. I don't know the length of PU yet, and I don't know the length of OU yet. Then I was given another triangle that I can see in here, which is this one here. So I'll draw it up like this. And that length is OTQ. Okay, this here is a right angle as well because of this 90 degree. So that's a right angle. And this is also given as a right angle inside the question. So OT, we don't know what that distance is. OQ, that is a radius line as well, just like OP. So that must be 10 units as well. And I don't know the distance of TQ yet. So to find this short distance TU, I would say it would be the length of OT minus the length of OU. So if I can find these two lengths, I will then have a length for TU. So let's try this out. Well, first of all, what was I given? Circle with center O, that's important. And that OT, which is this perpendicular line, is drawn to the two chords SQ and PR. So therefore, by the perpendicular line from center to chord theorem, I know that this perpendicular line bisects those two chords. So that means it cuts this chord into two equal pieces, and it cuts this chord into two equal pieces. But PR, this longer length chord, was 16. So that means this length must be 8, and this length must be 8. Similarly, we know that the perpendicular line bisects the chord SQ. So therefore, the total length of SQ was given as 10. So this must be 5, and this must be 5. But now look at that. We have the length of PU, which is 8, and we have the length of TQ, which is 5. We now can use the Pythagorean theorem to solve for those two lengths. So let's see what we've used. We've used circle with center O, and therefore with these two perpendicular lines here from the center, we were able to use the theorem. And then from there, we were given these two distance lines here, and we're able to half them because it bisects. So we've used these two, we've used these two, we've used the center, and OP as 10 was a radius line, which we used in these two triangles here. So we've used all the information, therefore we can solve the problem now. So let's write it out mathematically and rigorous. So here is our proof. We'll start off by stating that in triangle, well, first of all, let's do this. We will say that the line PU equals UR equals 8, and the reasoning is that we have perpendicular line from center bisects chord, and the other reasoning that we will use here was that PR was given as 16 units. Similarly, we can say that ST equals TQ equals 5 for the exact same reasoning, perpendicular line from center bisects the chord, and the fact that SQ was given as 10 units. We can therefore say in triangle PUO, we have that OP equals 10 units, that was given, that PU equals 8, that was found by this information here, and therefore by Pythag, we can solve for the length of UO or OU. So OU squared plus 8 squared equals 10 squared. So now we have an algebraic equation. So we therefore have OU squared plus 64 equals 100. Now I can subtract 64 on both sides and therefore get that OU squared equals 36. Now when I take the square root, I will get a positive or negative algebraically, but from the context of the question, we have a side length of a line in a triangle. So therefore OU must be the positive square root of 36, which is just 6. So this is 6 units long. Okay, similarly, we can do the same arguments for triangle OTQ using Pythag. So if I use Pythag on that triangle, I have 5 squared plus, and what is the missing length we are looking for? TQ squared equals 10 squared. So I have 25 plus TQ squared equals 100. Subtracting 25 on both sides, I get TQ squared equals 75, and therefore TQ must be the positive square root of 75, which simplifies to 5 root 3. Okay, so that is 5 root 3 units. So therefore OT, right, which is the larger length of the circle, 5 root 3, minus OU, which is 6, and we can leave that in simplified form. If you wanted it in decimals, so if we subtract 6, we get 2.66 units. So 2 decimal places. But this is more than perfectly acceptable, leaving it in its surd form. All right, so we've proven mathematically rigorously, step by step, giving every reasoning we can, and have used all the given information to successfully solve this question. All right, I'll see you in the next one.